Okay, everybody, the purpose of this is for you to be able to compare and contrast energy levels of atoms to cakes and how the energy levels, what their patterns are here, all right? Now, cakes come in all different shapes and sizes. These two cakes are different sizes, but they have the same numbers of layers, all right? And I'm going to compare these things, compare cakes to atoms, as I'll show you in a minute. Now, just for fun, whenever I think of cakes, I always think of Pollyanna. It's a movie about a young girl, and this is written by a woman who lived in Lancaster, New Hampshire, and look at these cakes. They're just like so beautiful. I don't know if you've seen the movie, but I just felt like I couldn't mention cakes without thinking of Pollyanna, without mentioning Pollyanna. All right, these two cakes are definitely different. They've got different layers and different sizes, all right, 3 and 5, as you can clearly see. This is kind of like atoms, because atoms have different layers, and the layers in an atom are the energy levels of an atom. And this cake's got 2 layers, and this atom has got 2 layers. For this analogy to work, think of like the cake as like just so you're taking a section of the atom, like a little slice, if you will. All right. Now, all these 4 atoms have 2 layers. You can see they have different parts, or excuse me, different numbers of parts, not different parts. All the parts are the same, but they all kind of have the same layering in that they all have 2 layers. Now, what's really kind of really cool is when you start to chart these things, in terms of where they are, this first atom is beryllium. And the way I know that, oh, I made it, there's a mistake. This atom is beryllium, but it's got two extra electrons, but that's okay. It's still got 2 layers. So this would be beryllium with a +2 charge. All right. This one would be boron, which is right there. And the last 2 are fluorine and neon. All of these 2 elements, all of these 4 elements are all in row 2, period 2. The period tells you the number of energy levels, all right? So any element in row 2 or period 2 has 2 energy levels. The amount of the parts on the energy level, the amount of electrons will vary. However, they have the same numbering, same number of levels. Now, as so across a period, number levels, and this is energy levels, same number of electrons and valence electrons goes up. All right. So as you go across a group, a period, any of them, the number of energy levels is going to be the same for all of these atoms. So sodium is going to have the same number of energy levels as chlorine in its neutral state, and so on and so forth. Rubidium, wicked good atom, palladium, and antimonium, they all have 5. All right? Now, As you go down a group, helium would have 1 ring, neon would have 2, argon would have 3, and krypton would have 4. So, as you go down a group, the number of energy levels goes up. The number of electrons goes up. The number of valence electrons, same. All of these elements have, well, disregarding helium, it's an exception, have 8, but each one has a different number of layers, different number of energy levels. And that's the pattern. As you go down a group, the number of energy levels goes up. As you go across a period, the number of energy levels stays the same. All right?